95% of the products issued from the chemical industry originate from processes that use at least one catalyst. Moreover, it's estimated that about 20% of the world economy, directly or indirectly, depends on catalysis. The development of new catalysts is thus a highly strategic issue with tremendous economic stakes. This is especially the case in the field of biorefineries, which are based on renewable sources. Catalysis is omnipresent in everyday life, most often in a completely imperceptible way. For example, catalytic processes are used in transportation for the production of fuels, tires, or plastic materials composed of polymers, in the field of health for producing active principles of medicines, in the field of the environment for air and water depollution, and in many other fields such as the textile and agri-food industries or construction. Depending on the nature of the catalysts, we can distinguish between chemocatalysis and biocatalysis. In addition to the development of new chemo and biocatalysts, one of the main challenges of the Realcat platform consists in developing a novel scientific field combining the best of these two technological variants through the hybrid catalysis concept. The innovation workflow in catalysis starts with a very first step based on fundamental research which is needed to explore new concepts. Then a trial and error experimental phase is carried out, which is not only costly but also time-consuming. This empirical approach is an unavoidable step, as catalysis is still not a predictive science. Rationalized interpretation of the as-obtained screening results further enables fine-tuning of the catalytic formulations before upscaling and subsequent commercialization. It's at the level of the trial and error phase that the Realcat platform provides a fantastic advantage compared to worldwide competitors. Indeed, the use of the high-throughput screening devices present in Realcat enables a substantial decrease in the length of this crucial step, dividing its duration by at least a factor of 10. Then, especially in the topical field of biorefineries, for which a large number of catalytic systems has still to be designed, Realcat enables a considerable step forward in a highly competitive world context by quickly developing solutions to hold tomorrow's key technologies. With a budget of more than 9 million euros, the Realcat platform comprises excellent equipment which is unique in the world, owing to the extensive integration on the same site of high-throughput screening tools enabling the synthesis, the characterization, as well as the testing of chemical catalysts, biocatalysts, and even hybrid catalysts. The Realcat platform is so flexible that it can also handle, for example, the execution of research programs in the domain of materials. The Realcat platform is composed of two connected zones. For catalyst synthesis, two fully robotized ChemSpeed platforms have been designed to enable operation in a wide range of experimental conditions. They're complemented with a glove box, giving the possibility of working under a controlled atmosphere. A large variety of characterization tools is also available on the platform, including a Bruker X-ray diffractometer, a Bruker X-ray fluorescence spectrometer, Bruker infrared and Horiba-Raman spectrometers, and an Agilent ICP coupled with a Vulcan mineralization robot. 3 Florence units from Avantium, as well as the aforementioned ChemSpeed platforms, are used to perform the catalytic tests. These devices allow to evaluate the performances of various types of catalyst in the gas or the liquid phase in 8 to 36 parallelized reactors and in a wide range of possible experimental conditions. These test tools are completed by fast offline analytical devices such as gas and liquid phase chromatographs and a gel permeation chromatograph. They've been designed to automatically treat more than 250 samples per day each. Most of these devices generate data that are collected and directed to the central server from which data processing and interpretation are performed. In the biocatalysis zone, the same philosophy has been applied. This zone consists in a laboratory specialized in microbiological, enzymatic, and bioprocess engineering. It comprises robots enabling high-throughput synthesis of mutant libraries by directed and random evolution of enzymes, as well as the screening of the as-obtained mutants. They're accompanied by advanced analysis and characterization devices specifically adapted to high-throughput technologies, as well as by tools for the separation and the purification of the target enzymes, and for the screening of the catalytic properties of the neo-synthesized biocatalysts. The Realcat platform is also equipped with a laminar flow microbiological hood. In this case also, the generated data are transferred to the central server. Finally, the combination of the equipment installed in both zones enables to take up one of the major challenges of the Realcat platform: developing hybrid catalysts for biomass valorization. The Realcat platform is open to research collaborations and to provision of service within the framework of academic and industrial partnerships. Please do not hesitate to contact us for any request you may have.